So what we're going to look at now is how we would process the results from titration experiments in order to find out our answers to the question being posed in the titration. If you want to do some reviewing of how you do a titration or make a standard solution, you can look at all the resources in the required practical section. There's plenty of resources and videos in there. So in this example, we've pipetted 25 centimetres cubed of sodium hydroxide and we've titrated it with hydrochloric acid. Now the 25 must have been in the pipette, that's the volume of a standard pipette, and the hydrochloric acid must be in the burette, so these titer values here are going to be of hydrochloric acid. So what I want you to notice, is something quite important for titration experiments, is that the convention for recording results is that the final burette reading goes ahead of the initial one so that we can do the takeaway without a calculator, although you are more than welcome to use your calculator. See if you can calculate the actual amount of hydrochloric acid that was released from the burette in each one of these titrations. So one thing to point out is that despite the fact that your calculator might give you the answer 21.8, you must keep the level of confidence in the numbers. So given that they were given to 2 decimal places, the last one ending in a 0 or a 5, that is what you should be giving your answers to. Now when we calculate the mean titer, we must only use the concordant results, those results that are within 0.1 centimetres cubed of each other. So ignoring the trial, looking at the accurate ones, these two are within 0.1 of each other, so they're the two that we're going to average, and when we average them we get 21.45. So how would we use those results to calculate the concentration of sodium hydroxide? What do we have enough information about? So we now have a volume of hydrochloric acid as well as a concentration. So if we've got a volume and a concentration, we can work out moles of hydrochloric acid. So the volume is 21.45, but remember that must be converted to decimeters cubed, and the concentration is 0.1. So you can type that on your calculator and you can work out the number of moles. Now what we know is that we're trying to use this to find information about sodium hydroxide. So we go back to our balanced equation and we look at how the two are related. And they are 1 to 1 in our balanced equation. And therefore, the number of moles of NaOH is exactly the same as the number of moles of hydrochloric acid. And given that we know that, we can calculate the concentration now because we knew the volume of sodium hydroxide, we were given it at the start. In chemistry, shorthand for calculating concentration is to put the formula of the chemical into a square bracket. And if it's in a square bracket, it means that we're calculating its concentration. And so we're going to do moles over vols, moles over volume. And we're going to remember that that volume this time was 25, but we're going to convert it to decimeters cubed, and we're going to get an answer of 0.0858, and the units of that will be mole dm minus 3, moles per decimeter cubed. So there's some examples in your pack. I want you to pause the video for each of these and work your own answers out. So the first thing you have to do is come up with a balanced equation and then see if you can answer the question. So there we go. The first thing you've got to get right is your balanced equation. If that goes wrong, there are going to be problems later on. And then we need to remember to convert volume in order to calculate moles, use the ratio, so for every 2 there's only 1, so we have to halve. And then calculate concentration, again remembering our conversion. I've given my answer to 2 significant figures because the data in the question was variable, but the concentration of sodium hydroxide was only 2 significant figures, and therefore I felt confident with 2 significant figures for my answer. So here's another one, see if you can have a go at this one. So there you go. Again, it's important to get that balanced equation correct, and then remember all those conversion factors. So at the end there, I've given my answer in centimetres cubed because it asked me to give it in centimetres cubed. Initially it came out in decimeters cubed, and I had to convert, and the conversion from in this direction would be times 10 to the plus 3, because I'm going from decimeters to centimetres rather than centimetres cubed to decimeters cubed.